All right, so we are getting started here, guys. So today we're talking about solving nonlinear systems. And we've talked before about systems of equations. In fact, back in Chapter 1, we did a little bit of that. The systems of equations that we did before, those are the ones where we had x, y, and z that we needed to solve for, and we had 3 equations. Well, we're going to scale it back here a little bit with what we're doing today. This is actually only going to be 2 equations and just x and y, not x, y, and z. So we're going to cut out that craziness, but we're going to be doing what's called nonlinear systems this time. Okay, so what do you suppose I mean by nonlinear? They are not lines. Okay, so guys, stop. Okay, so if we're going to do nonlinear systems, we're going to look at equations of things that don't graph lines and look for solutions to those things, but it's still more than one equation at the same time. So if I had just graphed 2 lines and I was looking for the solution, how many solutions could I have?
1 or 2.
And remember, the solutions are where those things cross. Linear ones, you could either have one solution. If it looked like something like this, where there's 2 lines that are crossing, it has one solution, that point where they cross. Could have no solution. Okay? That would mean that the lines never actually cross, so the lines would have to be what kinds of lines? Parallel lines. Or it could also have infinite solutions, which would mean that it's actually the same line. So 2 lines like sitting on top of each other. Okay? So with nonlinear systems, though, we can have things like parabolas in the mix. So if you have, let's say, like a parabola and a line together, then how many solutions could we have? Think about a graph of a parabola and a line on the same coordinate plane. You could have 2, right? Okay, so let's say you had your parabola like that and a line coming across like that. So this particular system would have 2 solutions. It would be the coordinates of those 2 points wherever they are. Okay? All right, if you had a parabola with a line, you could also have no solutions. Let's say you had a parabola that was like up here somewhere, and your line was coming across like this down here.
So you have to find the line and the parabola, right?
All right, so in that case, you'd have no solutions. Or you could also have just one in this kind of a situation. So maybe something like that. Now, it doesn't necessarily have to be at the vertex where that point would be, but you can have a line that just kind of like skims off a parabola like that, in which case there's only going to be one solution.
That linear line would have to be, how about like right down the middle of the parabola? Like where it intersects the parabola?
Yeah, it could be, if it was the line of symmetry coming right down the middle of it, that only intersects the parabola at one point, so you could have that situation too. Yeah. All right, so now, we're going to be looking at more than just a line with a parabola, but that's where we're going to start anyway, okay? We're going to look at what if you had a couple of parabolas together. We're going to look at what if there were circles involved in the system too. So we're going to do a lot of different things that way, but this is where we're going to get started, okay? And there are 2 different methods that we can use to find out where these points of intersection are, and that's using substitution or just graphing them on the calculator and looking. And there's a function on the calculator that will let you figure out exactly where those points of intersection are so that you don't have to do any of the hard work then for those. Okay? But again, I'm going to make you do both methods. So there's a non-calculator type and there's a calculator type depending on what I ask you to do. So let's look at this one first. So that first equation, y equals x squared, that's the parabola. The second equation, y equals x plus 2, that's the line. Okay? So this is a parabola line system like the 3 examples we had up at the top there. Okay? So we're going to do this one by hand. We're going to use substitution to do it. And if you remember, substitution was one of those methods that we used to solve systems back when we did just the linear ones too. And basically what that involved was if you have one variable equal to something, then you can replace that variable with that something anywhere else that you see it. Okay? So the way that this is written, y equals x squared, y equals x plus 2, y is equal to two different things, so I can replace y with whatever I want in either one. Okay? So that first equation, y equals x squared, I'm going to take this, x squared, and replace this y with it because y is equal to that. So we end up with that substitution, x squared equals x plus 2. So everybody catch what I just did there? Y is equal to x squared, so anywhere that I see a y, I can make it x squared. So that's what I did in the second equation. I just took the first y that I saw there, turned that into x squared, and there you go. Okay? So what we have right now is a quadratic equation, which we've been solving all through chapter 3 up to this point. Okay? So let's think about how we can solve that thing. We got all these different methods we've been talking about. What should I do to get this thing started?
Square root x plus 2. Right? So x equals the square root of x plus 2.
Actually, we don't want to square root both sides. Okay, so we can do that. We don't want to square root both sides because then we'd have an x under the square root and we wouldn't be able to solve for it anymore. But if we move the 1 over so that it's set equal to 0, now we've got some options. We can either use the quadratic formula like we did yesterday, or we could try to complete the square, or we could try and factor it, or any of those methods that we've talked about. So at this point, it's kind of up to you what you feel like is the easiest method for you. And sometimes, depending on the quadratic that you have, one method might be better than another one. Okay? So, I'm thinking quadratic formula. Everybody okay with that?
Yeah.
I think most of you probably would prefer that anyway. So, all right, so we've got to identify our a, b, and c. So a is -1, b is 1, c is 2. So, take those, plug them into the formula. We're going to have x equals -b, so -1 plus or minus the square root of 1 squared minus 4ac, all divided by 2 times a. All right, so everybody can see that? It's kind of small. All right, -1 plus or minus 1 squared minus 4 times -1 times 2 all over 2 times -1. So we simplify that square root up a little bit. 1 squared is 1. 4 times 1 times 2 is 8, but there's 2 negatives in there, so it's +8 still. So I can actually shorten this up a little bit. So we got 1 plus 8 under the square root then. And then 2 times 1 is, well, 2. -2, thank you. Okay, so square root of 1 plus 8. It's square root of 9, right? So it's 3. Yeah. Okay, so we've got -1 plus or minus 3 divided by -2. So we got 2 answers coming, right? One where we use the plus sign, one where we use the minus sign there. Okay, so if we add them up, -1 plus 3, I bet you can do this in your head. -1 plus 3.
2.
2 divided by -2.
-1.
-1. Okay, so x equals -1 is a solution. And then if we do the minus, -1 minus 3, -4 divided by -2, 2. Okay.
So that has 2
Okay.
solutions.
Yes. Okay. Now, remember, when we're solving a system, the solutions are points. They're ordered pairs. There's an x and a y with each. Right now, all I have are the x's. Okay? So think back to when we did solving systems. Once we had one variable, how did we find the other one? Go back and plug it in. Pick your favorite equation of the ones we started with and go plug them back in. It doesn't matter which one. As long as you've done your math correctly up to this point, you should get the same thing either way. Shh. Guys, be quiet, please. Levi, question?
So, up at the top, we had 0 equals negative x squared plus x plus 2.
Yeah.
Can't you, isn't that like how it like adds to x?
Oh, you want to do factoring?
Yeah.
Yeah, if you want, you could factor this, but what you'd have to do first before factoring it, yeah, so I would divide everything by -1, and then you'd be looking for what two numbers add to -1 but multiply to -2. And you could do that. You would be able to come up with a solution for that. So there are, like I said, there are lots of different methods that could work for these. So yeah, that's fine. In any event, so these two numbers that we came up with, we got to go back and plug them into one of these two equations that we started with. And like I said, it doesn't really matter which one. Okay, so let's say we plug it into the first one. Okay, the first x we came up with was -1. So what is the y that goes with -1? 1. Okay, if I plug it in here, -1 squared is 1. So the y that goes with this is 1. And then if x is 2, what's the y that goes with 2? 4. Right? 2 squared is 4. So y equals 2. All right. And because you have multiple solutions, I'm going to be a little bit more of a hard nose about this. You need to have these written as ordered pairs, because you need to know what x goes with what y and vice versa. So the two solutions would be the point -1, 1, and the point 4, sorry, and the point 2, 4. How to get what?
The x's into
You,
equation,
right. Either one. You could have plugged it into this one too.
Oh, okay.
You'd get the same result. You plug a -1 in for x here, -1 plus 2 is 1. You plug a 2 in for x here, 2 plus 2 is 4. So you're getting the same stuff either way. But these would be your solutions then, written as ordered pairs, -1, 1, and 2, 4. All right, so that's how you use that substitution method. So let's try one more doing some substitution and see how it goes here. So we got x squared plus x minus y equals -1, and then we got x plus y equals 4. All right, so if I'm going to use substitution, I'm going to have to do something with those equations to get started before I can ever start to try and do that. So what do I need to do to get started here? There were 2 equations in the last one. Mm-hmm. All right, so what you're essentially saying there is we need to solve these for y, right? That's what you were describing there? You were moving things around so we could solve them for y. Okay, let's do that. So this equation right here, this top one, if I was going to solve it for y, we could add y to the right and add 1 back to the left. So see if you can follow me here. It would be x squared plus x plus 1 equals y. You guys all see what I did there? Just add the y, add the 1. There we go. Got it solved for y. What do I need to do in the second equation to solve it for y? Well, you need to subtract the x, right? So it'd be, yeah, because you want to move the x to this side. So 4 minus x. Oh, I suppose you could do that too. Be a little more work that way, though.
That it would.
So, here are our two equations. We got x squared plus x plus 1 equals y. And then we got a 4 minus x that equals y. Okay, we got two things that are both equal to y. So this is kind of like we did last time. We're going to do a substitution. But it's going to be this equal to that, right? If they're both equal to y, those things I circled should be equal to each other then. You guys remember in geometry the transitive property? If A equals B and B equals C, then A equals C. Okay, you kind of link those things together. That's exactly what we're doing right here. Okay, if this is equal to y and y is equal to this, then this is equal to that, right? If they're both equal to the same thing, they're equal to each other. Okay, so we're just cutting out the middleman. We're getting rid of y, and we're just rewriting it as one equation just involving x then. So x squared plus x plus 1 equals 4 minus x. And now, all we have to do is treat it like a quadratic, move everything to one side, and then we got our choices again of what method we want to use to solve that quadratic. Yes, Liz?
Wait, so the x plus y equals 4 when you arrange that?
Which one? This one?
Yeah.
Yeah?
Did you just move the x over?
Uh-huh. I just subtracted x from each
I
side.
got x squared equals.
Just a second. So does that make sense, Liz, how I did that? Just subtracted x? Is a no response yes? I was asking you a question. Does that make sense now?
Yeah, that does.
Okay.
But the a equals b, c equals, did we make that? No, it's not how to.
So now you're asking about, like, now that we're down here, what do we do kind of a thing? Or oh, this whole thing right here. I'm just saying these two things that I circled, they're both equal to y. If they're both equal to y, they're equal to each other. That means that all three things are all the same, essentially. So that's how to get rid of y, was to just say that those two are going to be equal to each other. It's exactly what we did up at the top of the first one, too. Right? If y is equal to x squared and y is also equal to x plus 2, then x squared better equal x plus 2. It's all the same thing. Okay? It's using that same kind of logic to get it started. Now that y is gone, we can just move things over so that it's equal to 0 and do like a quadratic again. So I'm going to have to subtract 4 and then add x to either side. So I'm going to have x squared plus 2x minus 3. Yeah, minus 3. 1 minus 4 is negative 3, right? Everybody with me? Okay, so I'm going to do factoring on this one just because we haven't in a little while and it's good to brush up. So factoring is that process where we try to look for what two numbers add to the middle number but yet multiply to the last one. This one will factor, so we're going to do that. Okay? So what two numbers add to 2 but multiply to negative 3? 3 and negative 1, yep. X plus 3 and x minus 1 then would be the two factors for that. Okay, so if x plus 3 times x minus 1 equals 0, what are the two solutions then? Sarah?
Oh, I have a question.
Sure, go ahead.
So, for the x squared plus 2x minus 3.
Uh-huh. Mm-hmm.
So, you just feel like what multiplies to whatever?
What multiplies to this number, negative 3, and adds to this number 2? Okay, it's always multiply to the last one, add to the middle one. No, that's how you factor. That is factoring. That's how you figure out what two numbers are in your factors when you do that. Okay, so what are the solutions here, guys? -3 and 1. All right, so just like before, I got to just plug them in to one of the first equations. Now, it's probably easier if you go back to one of these two over here, and I would say this bottom one. Pick the one that's the easiest for you, okay? Y equals 4 minus x. Okay, so if x is -3, then what's y? 7, okay?
Wait, what do you do? 1 also.
Yep. So if I put a 1 in, what's y? 3. All right, so I've got two ordered pairs here again. I got -3, 7 is one point where these two things would cross, and 1, 3 would be the other point where these two things cross. Okay, so that time we use factoring. But again, I'm not going to force you to do factoring. It's whatever method you want. If you really like the quadratic formula and you wanted to just go with your A, B, and C and plug them in at that stage in that problem, that's fine. Okay, it's just what I chose to do on this one. So another one here for you guys to take a look at that's a little different. Good. So if we had a system like this, now that second equation we recognize as being a line. Okay, there's no x squared in there, so it's a line. Y equals -3x plus 10. It's got a slope of -3, y-intercept of 10. It's just a nice straight line. X squared plus y squared equals 10 is not a parabola. Okay, what about that equation up there, that first one, lets you know that it is not a parabola this time? It's got both x squared and y squared this time. If it was a parabola, it would just have x squared and that's it. Okay? So if you have both x squared and y squared like this, that's actually a circle. Now you guys studied these in geometry, but I don't know how much you guys remember. It's always kind of a loaded question, how much do you remember? But a circle, or an equation of a circle that you guys studied was like this. X squared plus y squared equals r squared. And that r means the radius of the circle. So this circle is centered at the origin and has what as a radius? Well, if it's x squared plus y squared equals 10, nope. It's the square root of 10. It's the square root of 10 because r squared equals 10. Look at the equation. It's always in the form x squared plus y squared equals. We had x squared plus y squared equals 10. These are the same. R has to be the square root of 10 to make that work. Okay? If r squared equals 10, the radius is the square root of 10. Okay? So this is a circle centered at the origin that has a radius that comes out to the square root of 10. Okay? And then there's going to be this other line that's going to come through and intersect the circle. And we need to figure out where does that line hit the circle. Okay? So, we can still do substitution here. Okay? Just not exactly in the same way that we did the last one. Okay? This first equation, don't touch it. Don't do anything with it to try and solve for anything. It's a mess. Okay? When you have both x squared and y squared, you have square roots that end up showing up all over the place, and you got to do the plus or minus, and it just doesn't work out nice. That second one has already been solved for y for you. Okay? Y is equal to -3x plus 10. Using substitution then, anywhere else we see a y, we can replace it with -3x plus 10. Okay? So I'm going to take the top. Okay? Just start writing that. X squared plus y squared. Well, if that's going to be y squared, I'm going to take this and I'm going to substitute it in for y, because that's what y is equal to, right? So instead of y squared, it's going to be that thing squared. Negative 3x plus 10 squared. Like that. And then don't forget equals 10. Now the reason that I did that, now I have an equation with no y in it anymore. Okay? I can work with that. It's quadratic again. I can solve quadratics. Okay? Now there's a little extra work on this one now, because I have to take that negative 3x plus 10 and square it, and then go from there. But it's at least doable.
Yeah, now don't you have to put negative 3x plus 10 again? And then do the time?
Yeah. Be careful. Be careful that you don't just make this 9x squared plus 100, because that's not it. If you have something in parentheses squared, it's the whole thing times itself, right? It's a very common mistake that gets made. So you got to FOIL that thing out, multiply everything to everything. So let's do that real quick here. Negative 3x times negative 3x is 9x squared. Negative 3x times 10, negative 30x. And then same thing with the 10. 10 times negative 3x, negative 30x. And then 10 times 10, 100. So if you combine the two terms together, what you actually have here when you square this thing is 9x squared minus 60x plus 100. Okay, so that quadratic right there is just the parenthesis part of that equation, right? We still got that squared on there, and it's still equal to 10. So we got to put it back in, okay? So we've got x squared plus all of that, 9x squared minus 60x plus 100 equals 10. Because this came from this, right? Right. Yeah, so now we got to start combining some like terms just to simplify this thing up, okay? So we got 10x squared minus 60x. And then if we take this 10 and subtract it over, plus 90, yeah? Question? Yeah, I guess so. All right, so I got 10x squared minus 60x plus 90. Now I'm free to use whatever method that I want. Now looking at those numbers, 10, 60, and 90, I could simplify this thing up just a little bit before I go and do anything else with it. Divide everything by 10. You guys see that? Everything's divisible by 10, so why not? Just get rid of the 10 in the front. So remember, I got to divide everything by 10, but that's no problem. Each one of those I can divide by 10 really easily. So it's x squared minus 6x plus 9 equals 0 still. So now, like if you were going to use your quadratic formula and you wanted to make your a, b, and c 10, 60, and 90, have fun with that. But I'm going to use 1, 6, and 9 instead and get the same answer. Okay? It wouldn't be wrong using those other numbers. It's just a lot more difficult to try and plug those in. So I'm going to go with this instead now. Okay? So, 1, b is negative 6, c is 9. If you'd like to use a different method, by all means, go for it. This one factors in everything, so you could do something else. But I'm going to use this. So, maybe so. 6, negative b would be positive 6. Square root of b squared, negative 6 squared, minus 4ac divided by 2a, or just 2, yeah. So we got 6 plus or minus the square root of 36 minus 4 times 1 times 9, 36. Huh. What's our discriminant going to be? Our discriminant is going to be 0. Right? So this is going to be 6 plus or minus 0 over 2, which is just 3. Because it's just 6 over 2 then. So this line and this circle have how many points of intersection? Only one. Okay, now I still got to find the y value of that point, right? So go plug that back in. It's not terribly difficult. Just put it in the line equation that we started with. If x is 3, negative 3 times 3 is negative 9 plus 10. It's 1. It's 1. So x is 3. That makes y equal to 1. So our ordered pair would be 3, 1. It is not, because this is not a parabola. Remember, it's a circle. So I'll show you what this thing looks like. If I graph the circle and this line, here's how it would look. We've got this circle. Just a minute. So we've got this circle that has a radius of the square root of 10, centered at the origin, and then we've got this line, negative 3x plus 10, that's coming like this. Okay? So you've got a line and a circle with one point of intersection. You guys remember from geometry when you talked about tangent lines? Yeah. So this is a tangent line to that circle. That negative 3x plus 10 is a tangent to that circle we started with. So there's only one point of intersection. Usually, with a circle and a line, you're going to have how many solutions? Probably 2. Okay, because if that line went right through the middle of the circle, you'd have 2, right? Now you could also have how many? You could have 0, because that line and that circle might never cross, so then you'd have 0. So 0, 1, or 2 when you're talking about a line with a circle. Okay? Think about a parabola in a circle. What if I did that to you? You could have how many?
4.
You could have up to 4. Okay? I don't believe they're going to do any of those to you. But if you put the two together, you could have up to 4 solutions then. What? Yeah, go ahead. So, that's doing it by hand. That's doing substitution. All right? You can also use your graphing calculator to make this process much easier. The circle one, unfortunately, you wouldn't be able to do on your calculator, because you can't graph a circle on your calculator. Not in the y equals menu. Now, any of the rest of it, though, any combination of parabolas and lines, you can do on your calculator. Okay? So let's take a look at a system, and we're just going to do this thing exclusively on the calculator using what's called the intersect command. So we're going to look at a couple of parabolas here. So we've got y equals negative x squared plus 4, and y equals 2x squared plus x minus 3. So we've done a bit of graphing already this year. So in your y equals menu, type both of those in. Okay, you've got lots of different places you can type in equations. So y1 should be the top equation, y2 should be the second one. That's right, they are. Should look something like that when you're done. If your graph is not in the same window as mine, if you just go zoom and then number 6, Z standard, it should look like mine then. All right, so with these two parabolas, how many points of intersection do we have? So we should have 2 solutions when we're done.
Interruption, as Thursday's fact for Bullying Awareness Week is read. 30% of young people have
All right. So we've got two parabolas. One opens up, one opens down, so we've got two solutions. Yeah? I guess so. Go ahead. So we need to figure out where those are at. Now, you can do it from this screen right here, or you can zoom in a little bit. You can change your window so that it's a little bit easier to see where those things are at. So let's do this real quick. If you go to Window, and we're going to change the X, min, and max, I believe -3 and 3. Let's do 5. We'll go -5 and 5, and then -5 and 5. And that's just going to make it a little bit closer so we can see where those are at. So here's the first parabola. There's the second one. It's a lot clearer this time. Okay. Now the calculator can pinpoint for us where those things are. Okay. You hit second and then trace, which takes you to the calculate menu. Now we've been here before. Remember when we found vertices? When we would look for a vertex of a parabola, we use the min and the max part of this. We've also found zeros this way, okay, on the graph. So there's a lot of things in this menu that we can use, okay? So we're going to use this time number 5, intersect. Okay? From here, it's super easy. You just see the little blinking cursor up there? You just move that to where you believe the intersection is. Hit enter 3 times.
Wait, how do you zoom in like that again?
I just changed the window.
All right.
I went -5 to 5 each way instead of -10 to 10.
Okay, thank you.
Yep. All right, yeah, just hit enter 3 times. And if you look this time, X and Y, they're not real nice numbers, but it doesn't always work out to nice integers like the substitution ones we did. So in this case, we've got -1.7 and then 1.1. So there's one of the 2 solutions.
Whoever makes the equations that come out nice,
Mm-hmm.
how good are they at everything? They're the smart guys.
They're the goodest. There's a second solution on here. So repeat the process. Second calc, intersect, and now just move it over to the other one. Oop. Enter 3 times. And there's the other one. So we round that thing off. We've got about 1.4 on the X, and the Y is about 2.1.
You said that was intersect?
Those are intersects, yeah. Okay? So our 2 points of intersection, or our 2 solutions to this system would be -1.7, 1.1, and 1.4, 2.1. Okay? So in your homework, you're going to have certain problems that say use substitution. You have to use substitution and show all your work. Just the answers are not going to cut it. There are other ones where it says use graphing. So just use your graphing calculator. You don't need to draw the graph or do anything. Just do what we just did and write the answers down. And there are other ones that say use elimination. I didn't teach you elimination because I didn't need to. Anything that you can do elimination, you can do substitution, and it works better, at least in my opinion. So you can use whatever method you want with those.
You can use graphing.
Sure, go for it.
So I don't have to show me work for that, right?
If you did the graph method, no. Okay? So that's it, all right? So you guys have a little bit of time started. So I'm going to let you have that to get going.